Quick ID soil tests are simple, useful methods of identifying soil properties and types, as dictated by ASTM procedure D-2488. This procedure allows us to identify a fine-grained soil's plasticity, dilatancy, toughness, and dry strength. Procedure. Preliminary classification can first be used to determine if a soil is coarse or fine-grained. Using sight and touch, approximate the percentage of fines in the soil. If the soil contains more than 50% fines, it is considered fine-grained, either a silt or a clay, and can be further identified through quick ID tests. Dilatancy. Dilatancy measures the expansion of a soil in reaction to shear deformation. To simulate this in a lab setting, we mold a 1-inch diameter ball of soil, adding water if necessary to facilitate the process, making sure the soil is soft and smooth, but not enough to be sticky. The ball is then placed in one hand and the surface smoothed out with a spatula. Cupping the sample in your hand, tap the bottom of your hand with your other fist several times and watch for water potentially rising to the surface of the ball. Next, squeeze the ball of soil and again, classify the reaction you see. The appearance of water can be described as none, slow, or rapid. Plasticity. Plasticity describes the point to which a soil can be deformed beyond recovery while still not experiencing cracks. The plasticity limit test, therefore, allows us to manually approach this limit with our soil sample. We do so by taking a small soil specimen and rolling it into a rope approximately 1/8 in diameter. If the soil can be rolled to this diameter without crumbling, ball the sample back up and repeat the process until the soil crumbles before it can be fully rolled. At this point, ball the soil up one last time and net it until it crumbles. For further analysis, you may mass the sample and place it in an oven for further water content testing. These results will be used in analysis of the soil's toughness, which refers to the stiffness of the soil as it reaches its plastic limit. Dry strength. We test for dry strength by watching how a dry soil crumbles under pressure. For this test, take a soil specimen approximately enough to make a 1-inch diameter ball, adding enough water to make it moldable. Once the balls have been dried, test their dry strength by crushing them between your fingers, taking note of the pressure required to crush the sample. Calculations and analysis. In our analysis, we use the observations we made from behavior of the soil during the quick test to classify these aspects of the soil's properties. Dilatancy. In the dilatancy test, we looked for the appearance of water at the soil surface with shaking or squeezing of the soil. The speed of the water's appearance, therefore, is used to determine the soil's dilatancy. A soil with rapid dilatancy is not able to hold on to its water, thus leading to its appearance on the surface. This would occur with silts. Clay, due to its ability to retain water, would contrastingly show no or very little dilatancy. Plasticity. In the plasticity test, we noted how long it took for the process of rolling the soil into a rope to result in the soil crumbling. The longer this process was, therefore, the higher we can say that the soil's plastic limit is, which is characteristic of clay, whereas silt would have had a lower plastic limit. Toughness. In analysis of toughness, we also use our observations for the plasticity test. If it took notable pressure to continue to roll the soil as it approached its plastic limit, we can say that the soil has a high toughness, more characteristic of clays. If the soil remained weak or soft, it was likely more silty. Dry strength. Dry strength is determined by a soil ball's crumbling when subjected to pressure. If the ball of soil crumbled on handling, it is considered to have no dry strength. This strength increases with the amount of pressure that has to be applied, up until the soil being unbreakable, yielding a dry strength of very high. The latter would be resultant from the soil being clay-based, while the former would likely contain more silt. Common sources of error. Due to the subjective nature of the quick ID soil tests, errors are common. The purpose of these tests is to identify a soil quickly to make assumptions about the behavior of the soil in the field. These tests do not yield numerical values for the engineering properties of the soil and are mainly used for ballpark calculations.